problem. Do the sum of the forces in the x, y direction free body diagram. Pause. Okay. First off, how do we do so far? Okay. In the y direction, the standing block is not moving. Okay. So it's at rest in the y direction, so we can say the sum of the forces are equal to 0. Okay. In the x direction, do they specify how the standing block is moving? No. Okay. So if you're not sure, then say not equal to 0, because to say it is equal to 0, that is a special case. Does that make sense? This is a safer assumption. Equal to 0, it's very specific. So if you're not sure, set it up equal to mass times acceleration. Does that make sense? You don't know. It could be, but it very well could not be. Okay? So there's your setup. Listen to this one. Now and only now will you pick up a calculator after you have this established. Okay? Now you might be thinking, well, that's silly. I might not need all of that stuff. You will come Friday. Okay? So do yourself a favor, invest in the full setup because it will be beneficial to you in a few days. Well, that's tomorrow. It will be beneficial to you tomorrow. Okay? So we are looking for what? Ultimately, we're looking for normal force. Where do we find that? The y direction. So if I can figure out this value and a value for this, I'm golden. Okay? So let's handle the angle first. Sorry, I forgot to have this conversation. I drew the 40 degrees here rather than here. What tipped me off, what told me to do that, is this phrase here, 40 degrees from the vertical. If it said 40 degrees from the horizontal or from the horizon or from the x-axis or something like that, then I'm drawing it here. Does that make sense? I got that from? Okay. So I've got a vector at an angle, and just like last chapter, if I have a vector at an angle, I need to break it up into components. And so I've got my y component and my x component, and my x component. So on this triangle relative to this angle is the red side the opposite, the adjacent, or the hypotenuse? The red side of the triangle relative to the 40 degrees. Is that opposite, adjacent, or hypotenuse? Adjacent. And I have a value for the hypotenuse. So I'm going to use what? Sine, cosine, or tangent? Use cosine. So cosine of 40 degrees is equal to F, or applied force in the y direction, over 50. At 38.3, is that right? So can I plug that in here? Okay. How am I going to get this? There? What is this a measure of? Mass. I need newtons. How do I go from kilograms to newtons? Nora? Okay, multiply by 9.8. On the test, do not just magically have this number appear out of nowhere. 2.45. Show me where that came from. Okay, coach me through, walk me through what you're doing. Like the original equation, plug in your math. I know this pain. Consider it just insurance, I guess. Okay. Can I plug that in here straight away? 2.45. There it is. At 38.3. Minus 2.45 equals normal force. Normal force is equal to 35.53 885. Good with that? Okay. Questions? Points of confusion? Okay. Next question. Tell your neighbor. Correct answer is B. Okay, what's another name for force of gravity? Weight. Okay. Correct answer is A. So do you see the difference? Acceleration of gravity, both of those are 9.8 meters per second squared in the negative direction. This is how much force of gravity there is. Or sorry, how much weight they have. This times 9.8. Good with that?
Yeah, the whole cafeteria full of well, they barely let us go.
Because that's the alternative.
They barely let us go anymore. What's that mean? Barely?
Just a little.
You have to do it from here.
Okay. You might have an intuitive feel for why the answer is the right answer, but do the setup, like free body diagram, sum of the forces in the y direction. Now, hopefully it looked like this. Tell your neighbor why the right answer is the right answer based upon your setup. Like mathematically, here's why they're like verified. Boom, this is the right answer because boom, 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 boom. All right, correct answer is A. Hopefully your conversation sounded like this. You're speeding up in the positive direction, therefore you have a positive acceleration. This quantity is positive. The weight didn't change, still 15 newtons. So in order to make this positive, this has to be bigger than this. You mean to run through that again? You have a positive acceleration, you're speeding up in the positive direction. Therefore, this quantity here is positive. To subtract these two, this number has to be bigger than this number. This is always 15. So this one has to be greater than 15. Good? Go ahead and modify your setup. Free body die, however you need it, like, or if anything changes. Tell your neighbor what the right answer is. Correct answer is? Correct answer is C. Good with that? Okay. It had to be greater than 15. Well, same scenario, just we're comparing it to the tension when it was hanging at rest. Modify your free body diagram and setup if you need to. Tell your neighbor. Okay, everybody good with B? All right, we're done with, no, we're not. One more fishing question. Tell your neighbor. Correct answer is B. It does not matter how fast you're going, so long as you're moving at a constant velocity, your inertia is happy. Now, you might have to get it going faster than, like, make it get to that speed, but that's not what I'm talking about. Once you've attained that speed, if you're moving at that speed, whatever that is, your inertia wants to continue moving at that same speed. Here's a more personal, maybe, experience. If you ever been driving in a really nice car, like something that had really good suspension, it's a smooth ride. You are, like, if you're a passenger on your phone, can you tell a difference when you're going like 40 miles an hour versus 80 miles an hour? If you're just like kind of zoned into your phone. Okay, because your body's in motion, it wants to continue in motion. Okay, not until you like do a turn or slow down, speed up, can you like feel anything. But just moving on. My grandma, her last car was a nice car, and like she didn't pay attention. Like she'd look down. Oh, I'm going 90. Like, grandma, don't do that. I was just listening to the music. It's just like you don't feel speed, you feel acceleration. Does that make sense? Thumbs up when you have an idea. Have a conversation. Around 9.8 to 10. Around 9.8 to 10. Okay, with these multiple choice questions in class, I use 10 instead of 9.8. Just to make things a little. Instead of 9.8, I use 10. Okay. Correct answer is C. Okay. You have two forces of tension going up. You have force of gravity going down. Force of gravity is not 50. It's 500. 250, 250 cancels out 500 going down. That make sense? Okay. Here's my recommendation. Set it up. Okay. Thumbs up when you have a guess. Okay. How many people set it up? You got this. If you didn't set it up, you probably got that. And you got it wrong because you didn't set it up. Because you just plugged in numbers into your equation. You're like, sweet. Got force, I got mass, force times acceleration. Boom. Okay. Set it up. You have to set it up. If you didn't set it up, you forgot about the force of gravity. You wouldn't have forgotten if you drew a free body diagram. You know, force of tension minus force of gravity is equal to mass times acceleration. Okay. Good with that? That'd be true if the elevator is in outer space. Then you can say that. 30. But it is not. Okay. The space shuttle is off the ground, but still on Earth. Thumbs up when you have a guess. Let's try it now. Thumbs up when you have a guess. Have a conversation. Those who set it up probably got D. Those who didn't said C. Those who didn't set it up forgot about gravity. They just used your numbers that was given to you. Got an acceleration, got a mass, multiply the two and get a force. Okay? What do you think I'm trying to drill home? Set it up. Okay? That's what I got for you today.